Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on tensor analysis, in which I will discuss about the concept of tensor is an extension of concept of vector. Before giving the main concept, I would like to give you some basics which will help to understand the main concept. The first concept is determination of direction cosines of a straight line. Let O be the origin and OX, OY and OZ be three axes in rectangular Cartesian system of coordinates. Let L be a straight line which makes angles alpha with x-axis, beta with y-axis and gamma with z-axis. Then cos alpha, cos beta, cos gamma be the direction cosines of the straight line L. We denote cos alpha by L, cos beta by M and cos gamma by N. Then direction cosines of the straight line L be L, M, N. Now let I vector be the unit vector along x-axis, j cap be the unit vector along y-axis and k cap be the unit vector along z-axis, and let eta cap be unit vector along this straight line. Therefore, eta dot I equal to scalar product of two vectors modulus of eta modulus of I, that is magnitude of unit vector I, and angle between this L and x-axis, that is along unit vector I, be alpha. This is cos alpha. Magnitude of unit vector eta equal to 1, magnitude of unit vector I 1, cos alpha, this is cos alpha and this is L. Similarly, eta dot j unit vector equal to cos beta, this is M, eta unit vector dot k equal to cos gamma equal to N. Therefore, we may determine the direction cosines of this straight line by taking dot product of unit vector along this straight line with unit vectors along x-axis, y-axis and z-axis. Our next concept is position vector of a point. Let P be a point whose coordinates be x, y, z. Then position vector of this point P is denoted by vector OP. and this is written as xi unit vector along x-axis plus yj unit vector along y-axis plus zk unit vector along z-axis. Next concept is Einstein summation convention and dummy suffix. We have an expression a1 x1 plus a2 x2 plus a3 x3 plus an xn. We may write this as sigma I 1 to n ai xi. But Einstein says that if a suffix I appears twice in a term, that is, this is a subscript and here superscript, then it denotes summation. So there is no need of using this sigma. So we may write this as ai xi. Here the suffix I appears as a subscript here and here superscript. This denotes this summation. This suffix is known as dummy suffix. That is, if a suffix appears as a dummy suffix, then it denotes summation. Now we will come to the main concept. Let P be a point whose coordinates be x1, x2, x3 and Q be another point whose coordinates be y1, y2, y3. Then vector OP equal to x1 unit vector I plus x2 unit vector j plus x3 unit vector k, and OQ vector equal to y1 unit vector I plus y2 unit vector j plus y3 unit vector k. Now OP vector plus PQ vector equal to OQ vector implies that vector PQ equal to OQ vector minus OP vector. This equal to OQ means y1 I plus y2 j plus y3 k minus x1 I plus x2 j plus x3 k. This equal to y1 minus x1 I plus y2 minus x2 j plus y3 minus x3 k. This is equal to a1 I plus a2 j plus a3 k, where yi minus xi equal to ai. I equal to 1, 2, 3. a1, a2, a3 are components of vector PQ. if we call this rectangular system of coordinates as x system of coordinates, then we say that a1, a2, a3 are components of vector pq in x system of coordinates. This is number 1. Now we have another system of coordinates, that is called x bar system of coordinates, in which O bar be the origin and O bar x bar be the x bar axis, O bar y bar be the y bar axis, and O bar z bar be the z bar axis. Let coordinates of O with respect to this system of coordinates, x bar system of coordinates, be order triplet a1, a2, a3. Therefore, O bar O vector equal to a1 I cap bar be the unit vectors along x bar axis, plus a2 j cap bar plus a3 k cap bar, means I cap bar be unit vectors along x bar axis, j cap bar be unit vector along y bar axis, and k cap bar be the unit vectors along z bar axis. Let coordinates of point P with respect to x bar system of coordinates be x bar 1, x bar 2, x bar 3, and coordinates of Q with respect to x bar system of coordinates be y bar 1, y bar 2, y bar 3. Therefore, O bar P vector equal to O bar O vector, this vector, plus OP vector, and this equal to A1 I cap bar plus A2 j cap bar plus A3 k cap bar plus OP vector in x system of coordinates. We write this x1 I plus x2 j plus x3 k, and we may write O bar P vector in x bar system of coordinates. This is x bar 1 I bar cap plus x bar 2 j cap bar plus x bar 3 k cap bar. This equal to A1 I cap bar plus A2 j cap bar plus A3 k cap bar plus x1 I cap plus x2 j cap plus x3 k cap, taking dot product with I cap bar. Here I cap bar dot I cap bar 1, that means x bar 1 Here I cap bar dot j cap bar 0, I cap bar dot j k cap bar, this is also 0, only remains left side x bar 1, and right side here I cap bar dot I cap bar 1 unit vector dot product. So this is A1. Here this j cap bar dot I cap bar 0, here also 0. Here we get x1 I cap bar dot I cap plus x2 I cap bar dot j cap plus x3 I cap bar dot j cap. Let direction cosines of x bar axis be L1, M1, N1. Then here I cap bar dot I equal to L1, L1 x1 plus I cap bar dot j, this is M1, M1 x2 plus this is N1 x3. Because we have already seen how to find the direction cosines of a straight line. Here O bar x bar be a straight line and unit vector along this straight line be I cap bar. Here unit vectors along x, y and z axis be I cap, j cap and k cap, and with the help of dot product of this unit vector along unit vectors along x axis, y axis and z axis, we get direction cosines. So with the help of this concept we have found these direction cosines L1, M1, N1 of the straight line O bar x bar. Let this is number 2. Now taking dot product j cap bar in both sides of this equation, we get x bar 2 equal to A2 plus L2 x1 plus M2 x2 plus N2 x3. This is number 3. And x bar 3 similarly taking dot product k cap bar in both sides of this equation, A3 plus L3 x1 plus M3 x2 plus N3 x3. This is number 4. We may generalize 2, 3, 4 as x bar I equal to AI plus Li x1 plus Mi x2 plus Ni x3. I equal to 1, 2, 3. Let this is number 5. Similarly, y bar I equal to AI plus Li y1 plus Mi y2 plus Ni y3. This is number 6. implies that y bar I minus x bar I equal to, here ai cancel, we get y1 minus x1 li plus y2 minus x2 mi plus y3 minus x3 ni. Since we have seen that here y1 minus x1 equal to a1, we may write this a1 li plus a2 mi plus a3 ni, and left side we may write a bar I. So a bar I equal to a1 li plus a2 mi plus a3 ni. This is number 7. Here I equal to 1, 2, 3. Now differentiating both sides of 5 with respect to x1, x2, x3 respectively, we get, here if we differentiate this equation with respect to x1, we get del x bar I left side by del x1 equal to this li del x bar I by del x2 equal to mi here, and del x bar I by del x3 equal to ni. Let these equations be 8. Putting these values in 7, we get a bar I equal to, here li means del x bar I by del x1 a1, here mi means del x bar I by del x2 a2, and here ni means del x bar I by del x3 a3. Here we see that suffix 1 1, here 2 2, here 3 3. So we may use the concept of Einstein summation convention, that is dummy suffix. So we write a bar I equal to del x bar I by del x alpha, a alpha, alpha be the dummy suffix, and I equal to 1 2 3. This is number 9. Here we see that we get 3 components of vector PQ in X system of coordinates A1, A2, A3, and in X bar system of coordinates A bar 1, A bar 2, A bar 3. So this is the relation between the components of vector PQ in both system of coordinates. This is the relation between components of vector PQ in both system of coordinates. Let the components of a vector PQ constitute an ordered set. This is a set containing A1, A2, A3 as elements in X system of coordinates. These components are in X system of coordinates. Let another ordered set containing elements B1, B2, B3. These are components of a vector Rs in X system of coordinates. Now let us take the Cartesian product of these two sets, and which will be another set containing 9 elements. These 9 elements. Now let us think about a physical quantity whose components are these elements in X system of coordinates, and corresponding quantities in X bar system of coordinates be A bar I, B bar j, I j equal to 1, 2, 3. And let, similar to 9, the components in two system of coordinates be as A bar I, B bar j. For this we write this partial derivative del x bar I del x alpha, and for this we write the partial derivative del x bar j by del x beta, and here A alpha, B beta. Let we write A bar I, B bar j as Aij. Then this equation reduces to A bar Ij equal to del x bar I del x alpha del x bar j del x beta A alpha beta. This is number 10. Here we see that in right side we have 9 components: A11, A12, A13, A21, A22, A23, A31, A32, A33, and here also left side we get 9 components in X bar system of coordinates. In a vector we have only 3 number of components along x-axis, along y-axis, along z-axis, but here we get 9 number of components in any coordinate systems. So these components may not be the components of a vector. We call these physical quantity as tensor. These components are components of a tensor. Here we get components of a vector. In a vector we get 3 components, and here 1 partial derivative, here 2 partial derivatives. So we may call this vector as a tensor of rank 1 for existence of 1 partial derivative, and we call these physical quantities as tensor of rank 2. And this kind of vector tensors are called contravariant vector contravariant tensors. This is the contravariant tensor of rank 2. This is a contravariant vector of rank 1. In place of Cartesian system of coordinates, if we use n-dimensional space, and in that system number of components in X system will be n, a1, a2, a3 dot 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 an, and for rank 2 we get number of components n square, and we may write in generalized form contravariant tensor as a bar I j dot 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 k equal to del x bar I by del x alpha, del x bar j by del x beta dot 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 del x bar k by del x gamma a alpha beta dot 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 gamma. This is number 11. Here, this is the tensor law of transformation for contravariant tensor. We may write vector in another form. Let phi be a scalar valued function. Phi be the function of x1, x2, x3. Navla phi is a vector. We may write Navla phi equal to I del phi by del x plus j del phi by this is x1 del phi by del x2 plus k del phi by del x3. Here components are del phi by del x I 1, 2, 3. So 3 components. These components are components of a vector. Since Navla phi is a vector, let x bar I be the coordinates in x bar system of coordinates. Since we know that x bar I, this coordinate depends upon x1, x2 dot 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 xn, means these are coordinates in x system of coordinates. If a Jacobian not equal to 0, then we may write xi be the function of x bar 1, x bar 2 dot 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 x bar n. Now we write del phi by del x bar I equal to del phi by del x1, del x1 by del x bar I plus del phi by del x2, del x2 by del x bar I plus dot 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 plus del phi by del x n, del x n by del x bar I, because phi be the direct function of x1, x2, x3 dot 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 xn. Here we see that here 1, 1, here 2, 2 dot dot n, n. So the we may write this in the form of dummy suffix. That means del phi by del x alpha by del x bar I. We may write this as del phi by del x bar I equal to del x alpha by del x bar I del phi by del x alpha. Let del phi by del x alpha equal to A alpha. Then we may write A bar I equal to del x alpha by del x bar I A alpha. This is number 12. Here we see that A1, A2, An are components of another kind of vector, and corresponding components in x bar system of coordinates be A bar 1, A bar 2, A bar n. These components are components of the vector in x system of coordinates, and these components are components of the vector in x bar system of coordinates, and this is the transformation rule for obtaining components in x bar system with the help of components of x system of coordinates. And this type of transformation is known as transformation by covariance, and component of these vectors are covariant vectors. This is for rank 1. For rank 2, A bar ij equal to del x alpha by del x bar I del x beta by del x bar j A alpha beta. Similarly, for mixed tensor, we may write mixed tensor, contravariant and covariant both. A bar ij equal to, for contravariant, del x bar I by del x alpha del x beta by del x bar j A alpha beta. Let this is number 13, this is 14. With the help of concept of 9, we get concept of 10. In 9, we get the vector concept, and in 10, tensor concept. Similarly, with the help of 12, we get concept of 13. Here vector concept, here tensor concept. So we may conclude that the concept of tensor is the extension of the concept of vector. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.